Good morning, Mr. Ahmed here. Goal for today is to start up Unit 0. This video is going to go over Unit 0-1, which will be used with Worksheet 0.1 on solving equations. You will get this note packet when you're in class, so A-Track students, you're going to get it on Tuesday, and B-Track students, you'll get it on Thursday. We will only have one worksheet this week that will be assigned. I will also get that to you when you arrive. If you would like to print it off and work ahead, you are free to do that. The link to print it off is also on PowerSchool Learning. So our goal for today is to solve equations. So essential question is, how do I solve an equation? For the most part, we went over this quite a bit last year in intermediate algebra, but the steps, a couple things about an equation. First thing, an equation has an equal sign. And on each side of the equal sign, I'll just look at example 1. For it to be true, the value on the left has to be the same as the value on the right. In order for us to solve it, our goal will be to isolate the variable, and that will tell us what x has to be to make the equation true. The process, a couple things we have to do. The first thing, if we see parentheses, the first thing we're going to do is distribute. Okay, remember the distributive property, we'd see a set of parentheses, 2 parentheses, x plus 4. For us to distribute that, we'd multiply the 2 to the x and also the 4. So 2 times x plus 4 is equal to 2x plus 8. I multiplied 2 times x and I multiplied 2 times 4. So if you see parentheses, distribute first. Next thing we're going to do is combine like terms that are on the same side. Okay, so if we see like terms on the same side, we will combine them. Keep in mind, like terms, same variables raised to the same powers. And then finally, we'll use inverse operations to isolate the variable. So first example, starting off pretty straightforward. It says 4x plus 5 equals 9. For us to isolate the x, we have to get rid of the 5 and the 4, and then x would be by itself. So inverse operations, we want to add and subtract before we multiply and divide. So since I have a plus 5, the opposite of plus 5 would be minus 5. But if I subtract 5 from one side, I have to do it to the other side. Sometimes it's helpful to draw a line where the equal sign is, so it's obvious what's on the left and what's on the right. 5 minus 5 cancels, and we get 4x is equal to, 9 minus 5 is 4, and 4x equals 4. 4 times x. Opposite of times is to divide. So I'll divide both sides by 4. The 4's cancel, and x is equal to 1. We found the solution. If I put 1 back in, it would make it true. Okay, next example. This one looks like we have x divided by 4. The opposite of divide is to multiply, so I'm going to multiply both sides by 4. If I do something to one side, I always have to do it to the other. 4 times x over 4, the 4's will cancel, and x is equal to, negative 3 times 4 is negative 12. I will circle my answer. So as you work on your worksheet, your work should look like this. We need to show our steps as we're going. Next example says 10 equals 8 minus 3x. Sorry, 8x minus 3x. So these are like terms. We have an 8x and a 3x, okay? They both have an x raised to the first power, so I can combine them. They're on the same side. So I would leave my 10 alone. There's nothing else on the left. Equal sign still there. 8x minus 3x is 5x. Combined them. 8 plus negative 3 is 5. And now we have 5 times x, so to isolate the variable, we'll divide both sides by 5. And 10 over 5 is 2 equals x. And I could flip that around and say x equals 2, 2. Choice is yours. Example number 4. Almost lost my camera there. We'll rearrange here, regroup. Not a big deal. But next example says 3 over 4x plus 2 equals negative 1. We cannot freak out. We see a fraction, that's okay. We can still solve it. All right. So again, 3/4 times x plus 2. Add and subtract before we multiply and divide. So I want to move the 2 first. I will subtract 2 from the left side. If I do it to the left, I also have to do it to the right. 3 over 4x equals, these 2's canceled. Negative 1 minus 2 is negative 3. Now, with the fraction, there's a couple ways you could do it. You could divide both sides by 3/4. That's fine. All right, 3/4 is 0.75, so you could take out a calculator and take negative 3 divided by 0.75. That's okay. But I'm going to do it with the fraction. in order to get rid of a fraction, I multiply by its reciprocal. The reciprocal of 3 over 4 is 4 over 3. That'll make the 4 over 4 cancel, and the 3 over 3 will cancel. So if I multiply the reciprocal, it cancels out this fraction. If I do it to one side, I also have to do it to the other, so this is times 4 over 3. X is now by itself, equals. Now, when you multiply fractions, this negative 3 is over 1. Negative 3 times 4, straight across, is negative 12. Negative 12 over 3 is negative 4. You could also type that into a calculator if you so choose. Option is yours. Next example, number 5. Again, I see the parentheses this time. So when I see parentheses, I have to distribute first. So, distribute. 5 times x is 5x. Plus 5 times 2 is 10 equals 15. Use the distributive property. Now we're just going to isolate the variable. Subtract the 10. Cancels out. 5x equals 5. Now we'll divide both sides by 5. And x is equal to 1. You could always substitute that back in to check your work. Another distributive problem here. Now when I distributed negative 3, I have to make sure I multiply by a negative. So negative 3x times 4x is negative 12x. A negative times a negative turns to a positive 24 equals negative 36. Next step, move that 24, add and subtract first. So I got to subtract 24 from both sides. And that's kind of a big one. Negative 36 minus 24. If you need to use a calculator, feel free. And we'd get negative 60 is equal to negative 12x. And finally, divide both sides by negative 12. Careful here, negative divided by a negative changes to a positive. And x is equal to positive 5. So, finished up page number 1 of our notes. Moving on to our next set of examples, we have 4 left. I will always try and keep these videos right around 10 minutes. Hopefully we can keep it there, keep the attention rolling. So next example, this one's getting a little bit tougher now. I have some like terms on the left, so I got to combine them. The 8 and the 7 can be combined together. Those are constants. 8 plus 7 is 15. So 2x plus 15, I simplified the left side, is equal to 4x plus 3. Now in this problem, we have variables on both sides. We have to round them up, bring the x's together. I always move the smaller one. That way I'm working with positive numbers. 2x is smaller than 4x, so I'm going to move the 2x to the other side. I can't combine them because they're on different sides. So for me to bring this 2x over, the opposite of plus is minus, so I'll subtract 2x from both sides. 15's left on the left, equals 4 minus 2 is 2x plus 3. Next step. Move the 3, subtract it, and I got 12 is equal to 2x divided by 2, and 6 is equal to x. Okay. A little bit tougher here on number 8 as well. I see like terms. I have x's on the left and I have constants on the left. Round up my x's. Since they're on the same side, I combine them. An x with nothing in front of it is the same as a 1x. So 1x plus 5x is 6x. I round up my 20s and my 10. Those are constants. Those are like terms. Combine them. 20 plus 10 is 30. 6x plus 30 is equal to 180. Subtract my 30. And we got 6x equals 150. And 150 divided by 6 is 25. Should have known that one. I used a calculator. All right. We're going to look at the very last 2 examples here. Number 10's pretty tricky. 9's not bad. So for number 9, left side, no like terms. Right side, parentheses, have to distribute. So I'm going to rewrite the left side, negative 16 plus 5x equals, distribute. Negative 7 times 8 is 56. So we have negative 56x. Negative 7 times negative 6 changes to a positive. Got to be careful there. And we get 42. And our plus 3 is still there. Okay, Okay, we don't distribute to the 3 because the 3 is outside of the parentheses. Combine like terms. Negative 56x plus 45 is equal to negative 16 plus 5x. All right. Round up our like terms. Negative 56x is smaller than 5x, so I'm going to add the 56x to both sides. And I have negative 16 plus 61x is equal to 45. And then I add 16 to both sides. And 45 plus 16 is 61. So I have 61x equals 61. And we'll divide both sides by 61 to isolate the x, and x is equal to 1. So it turned out to be a pretty nice number there at the end. Last one. This one's a little bit tricky with this division. All right, the 2 is not being divided, so again, we want to add and subtract before we multiply and divide, so I'm going to move the 2 first. Subtract 2 from both sides. 2x plus 3 over 6 is equal to 5 minus 2, which is 3. Now, since this entire part is being divided, I can get rid of this division by multiplying both sides by 6. 6's will cancel. 2x plus 3 is equal to 18. And from here, minus the 3, 2x is equal to 15. Oh, divide by 2. And x is equal to 15 over 2, but that's not a whole number. That's okay. We can have some fractions. You can call that 7.5, or you can leave it as 15 over 2. I'm going to leave it as 15 over 2 and call it a day. So we will have a couple fraction answers. All right, we will have some time to go over questions on solving equations and working on the worksheet in class, both for A track and B track. Have a great rest of the day.